Part 3 starts from here. Rule 6. In covalent compounds, compounds of two non-metals, the non-metal atom with higher electronegativity is assigned negative oxidation number, and the non-metal with lower electronegativity is assigned positive oxidation number. So when we are talking about the covalent compounds, we are talking about compounds which consist of two non-metals. This is like one non-metal, then we have another non-metal. So in this case also, the non-metal which will have higher electronegativity will be given as negative oxidation number, and the one with the lower electronegativity is given as positive oxidation number. For example, in this case, chlorine has more electronegativity as compared to hydrogen, so it will be assigned the negative oxidation number, which is -1 in this case, and the hydrogen will have +1 in this case, as per the rule 3, which state that in compound with non-metals, the oxidation number of hydrogen is +1. Now let us take second example. This is NH3. Again, out of nitrogen and hydrogen, nitrogen will have more electronegativity as compared to hydrogen. So nitrogen will be assigned the negative oxidation number. In this case, it will be -3, and hydrogen will be assigned positive oxidation number. In this case, it will be +1. Again, as per the rule 3. This compound consists of nitrogen and chlorine. Out of nitrogen and chlorine, chlorine is more electronegative as compared to nitrogen. So chlorine will be assigned the negative oxidation number. In this case, it will be -1, whereas nitrogen will be assigned the positive oxidation number, which is +3. Rule 7. In neutral molecules, the sum of oxidation numbers of all the elements in a compound is 0. Neutral molecules are those molecules whose overall charge is 0. That means the total sum of positively charged ions is equals to sum of the negatively charged ions. That is why the overall charge is 0. So in these molecules, the sum of oxidation number of all the elements in a compound is 0. Let us take two examples. This is CH4 and H2SO4. Now, as per the rule 3, hydrogen will have the +1 oxidation number, and the carbon will have -4. So if we see the overall charge on the carbon is -4, whereas the overall charge of hydrogen will be +4. Why? Because one hydrogen atom has an oxidation number of +1. So 4 of them will have the total charge as +4. So methane molecule is overall a neutral molecule. The overall charge is 0. Same here. As hydrogen is with sulfur and oxygen, which are more electronegative and they are non-metals, so as per the rule 3, the hydrogen will have the +1 oxidation state. Now, out of sulfur and oxygen, oxygen is more electronegative as compared to sulfur as per the rule 6. So sulfur will have a positive oxidation state, whereas the oxygen will have the negative oxidation state. And in this case, sulfur will have +6 and the oxygen will have -2. Again, how I have found out this oxidation state, for that you need to see the video related to steps for writing the oxidation number of different elements. So now if we calculate the overall charge, the overall oxidation number of hydrogen will be +1 into 2 atoms. This will be +2. The sulfur will be +6. So the total positive charge is +8. And if we calculate the total negative charge, oxygen has a charge of -2 and there are 4 atoms, so it will be -8. So if you see here, the total negative charge is equal to total positive charge. So the sulfuric acid molecule is overall neutral molecule. That means the overall charge is 0. The last rule, the 8th rule. In polyatomic or complex ions, the sum of oxidation numbers of all the atoms present in ion is equal to the net charge on the ion. When we are talking of some complex ion, so the sum of the oxidation number of ions present inside will be equal to the net charge on ion. For example, SO4 2 negative. Now this complex ion has a overall charge of -2, which is the net charge. So now as per this rule, if we take the oxidation number of sulfur and if we take the oxidation number of oxygen and if we add them, so their answer should come out to be -2. In this case, the oxidation number of sulfur will be +6 and the oxidation number of oxygen is -2, and there are 4 of them, that will be -8. So if we add the oxidation number of sulfur and the oxidation number of oxygen, then it is +6 -8, so it will come out to be -2, which is equal to the net charge on this complex ion. So that was all about the rules for assigning oxidation numbers. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.